Let's talk about one of the most brilliant and kinda unsung heroes of the internet, route summarization. It sounds technical, I know, but you'll see how a super simple idea, one we basically stole from snail mail, is the very thing that keeps our entire digital world from grinding to a halt. I mean, really think about it for a second. How does the internet not just collapse? You've got billions of devices, millions and millions of websites, all chattering away. How does a little packet of data from your phone find its way to a server halfway across the globe in like a fraction of a second without getting hopelessly lost? How does the whole system not just buckle under that sheer weight? Well, at the heart of it all are these little boxes called routers. Their job is to direct all that traffic. But here's the problem. If every single router had to know the exact address of every single destination on the internet, its brain would just melt. We're talking millions of routes. The memory, the processing power, it would all be completely overwhelmed. It's like asking your local mail carrier to memorize every single street address in the entire world. It's not possible. So, to get our heads around the incredibly clever solution, we're going to step away from the digital world for a minute. Let's look at something we all know, the good old postal service and the genius of the zip code. This right here, this quote, just nails the whole concept. Think about it. A mail sorter in Atlanta doesn't need to care about 123 Main Street in San Francisco. All they need to know is, okay, this one's going to the 941 whatever area. They just group it with all the other San Francisco mail and ship it off. The hyper-specific details, that's someone else's problem, further down the line, right? It all happens in these logical stages. Your letter first gets a really broad sort, probably by state. Once it lands in that state, it gets sorted by city. Then, at the city's main hub, it's sorted by neighborhood or zip code. And only at the very last step does the local carrier need to know the specific house number. Each step gets more and more specific. It's this hierarchy that makes the whole thing work so efficiently. And you guessed it, this is exactly what the internet does. It uses its own digital version of a zip code to handle the absolute avalanche of data flying around every single second. It's all about summarizing information. The official name for this magic trick is route summarization, or sometimes you'll hear it called supernetting. All it means is that instead of a router shouting about, 20 different specific networks it knows about, it can just send out one single general announcement. It's basically telling its neighbors, hey, anything for this whole general area, just send it my way, I'll handle the details. So how does a router actually do that? How does it figure out that common part of the address, that digital zip code? Well, for that, we got to peek under the hood and look at these addresses in their native language, ones and zeros. Okay, don't let the binary scare you. What's happening here is actually pretty simple. The router takes a list of networks, in this case, 8 of them, and it lines them all up. Then it just plays a game of spot the difference. It looks for the longest string of ones and zeros from the beginning that is exactly the same for all of them. You can see the first 2 big chunks of numbers are identical. The pattern only breaks in that third block. It's just a super fast game of pattern matching. And what's the result of that game? Well, for these 8 networks, it turns out the first 21 bits are a perfect match. That shared part, that is our digital zip code. It's the common region that holds all 8 of these more specific little neighborhoods. And this, right here, is the payoff. The router can now take those 8 separate lines of information, toss them out, and replace them with this one beautiful, clean summary route. That little /21 at the end is just telling other routers, hey, the zip code for this whole area is defined by the first 21 bits. We just compressed 8 facts into one. Now imagine scaling that up across thousands and thousands of routes. It's a game changer. Now, this isn't just a neat little trick for saving space. This efficiency has a massive, profound impact on the actual health and stability of the entire internet. It's the difference between a free-flowing superhighway and a total, constant traffic jam. Just look at the difference. Without this, routers are working overtime, their memory is maxed out, and they're constantly gossiping about every tiny little change on the network. But with summarization, their workload plummets, and the whole network just gets calmer and more stable. It even stops problems like flapping routes. That's where one unstable network keeps connecting and disconnecting, from causing a domino effect of chaos across the internet. The summary route basically hides that local problem from the rest of the world. So let's just quickly recap the massive wins here. We're grouping networks together logically, just like zip codes. This saves a ton of CPU and memory on the hardware that runs the internet. It drastically cuts down on background noise, and it makes the whole network way more stable and resilient for all of us. And you know what? The idea doesn't even stop there. There's an even more advanced technique called VLSM that lets network engineers get even more granular. They can create summary regions of all different sizes. It's like having some zip codes for a single huge apartment building and other zip codes for an entire rural state. It's all about making the summary a perfect fit for the need, squeezing out every last drop of efficiency. So, route summarization is just a perfect example of this invisible, super intelligent design that makes our incredibly complex digital lives possible. It kind of makes you wonder, doesn't it? What other elegant, hidden systems like this are working quietly in the background every single day, just keeping the whole show running?